All right, so the next question reads, how do you find the square root of 20? Okay, so the method I like to use is to find the prime factorization of 20 and then to simplify it so that we can find the simplified radical form. Okay, so the prime factorization of a number is basically to reduce it to its factors, and factors are basically numbers that when multiplied together produce the original number. So they're the multiples of 20 basically. So prime factorization is breaking the number down into its prime factors. So these factors are what are prime numbers, and prime numbers are irreducible from that point. And what I mean by irreducible is only divided by 1 and itself. Okay? So first let's try to find the prime factorization. But the other piece of information that we need to use here is these two properties. First of all, the square root of a number that is squared is going to be just the number itself. So if you think about it, you square the number, but the square root reverses the square of the number, so you just get the number itself. And the other property that we want to use is the square root of the multiplication of two numbers can be written as the square root of one number times the square root of the other. Okay, so we're going to use these two properties to help us find the square root of 20. Okay, so first we want to break down 20 into its prime factors. So first we want to think of the factors of 20. So a factor of 20 can be 2 and 10, right? So 2 times 10 equals 20. We could also use 5 times 4, but we're going to use 2 times 10 for our example. Okay, so we see here in our factors here that 2 is a prime number, so it's a prime factor, but 10 is not. So we have to further break down 10. So what are the factors of 10? Well, it could be 2 and 5, right? So now if we look at this, we see that 2 and 5 are both prime numbers, so we have now found the prime factorization. So 20 is equal to 2 times 2 times 5. So if we were to use 5 times 4, for example, we see here that 5 is a prime number, but 4 is not. So we can break 4 down further into 2 times 2. And now we have found the prime factorization through the 5 times 4 route, which is the same as the 2 times 10 route. So that's a very important message about prime factorization, that every number has the same prime factorization, or has its own distinct prime factorization. So no matter which way you go, for example, if you have a really big number like 144, for example, if you find different factors of 144, if you break it down in the end, it'll always be the same prime numbers. Okay? So moving on, let's say that we have the square root of 20 here. Well, the square root of 20 can be written as the square root of 2 times 2 times 5. Right? So 2 times 2 times 5. Right? So we see here that 2 times 2 can also be written as 2 squared. And using our second property that we stated, we can break up the multiplication of two numbers in a square root by doing this. So the square root of 2 squared times the square root of 5 is equivalent to the square root of 2 squared times 5. Using our first property, we realize that the square root of a squared number is just the number itself, so we have 2. And finally, we cannot square root 5 into a whole number, so we're just left with the square root of 5. And that is the square root of 20, which is 2 times root of 5, and you can use a calculator to approximate what root of 5 is. So other than that, the solution is correct, and we can move on. Okay, so question number 5.